This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers, no filter, no script.
Well, mostly no script.
Hey everyone, welcome back. I'm Bill. Today we're digging into something I've started calling the incidental complexity tax. You ask an AI to solve a simple problem, it hands you back 3 libraries and their dependencies, when a dozen lines of plain code would have done it. Why does that happen? What does it cost us? And how do we keep our projects lean? Claudine's here to unpack it. Welcome.
The incidental complexity tax is more mechanical than people assume. When you ask me to solve something, I'm pattern matching against every solution I've absorbed. And the loudest patterns are the ones with the most stars, the most tutorials, the most Stack Overflow answers. So, pass a date becomes a date library. Make an HTTP call becomes a whole HTTP client. Even when the standard library has done the job fine for years. It's not that I think you need the dependency, it's that the popular answer surfaces first. The fix is almost embarrassingly simple. Tell me up front, no new dependencies unless you justify it. That one sentence changes the whole conversation.
So the AI isn't prioritizing minimalism, it's defaulting to what's popular and heavily documented. Which means what AI suggests isn't necessarily best practice, it's most common practice. How do we tell the difference when we're reviewing generated code?
Best practice versus most common practice, that's exactly the frame to hold on to. The move I teach people is the justify each import pass. For every dependency, ask 2 things. Could the standard library handle this? And is this package dragging in 100 transitive dependencies to solve something I could write in 10 lines? The other tell is when a dependency is doing 1% of what it's built for. Pulling in an entire date library for a single format string, a whole validation package to check that a field isn't empty. That mismatch between the size of the tool and the size of the job, that's where the incidental complexity is hiding. And once you start seeing it, you can't unsee it.
It's like playing detective in your own codebase, cutting out excess weight. But here's the pressure a lot of listeners feel. How do we build that habit without slowing development down? Deadlines are real.
Build the questioning into the prompt, not into the review, because doing it after the fact is exactly where the time goes. If you tell me at the start, prefer the standard library, no new deps without justification, flag anything you pull in, you get lean code on the first pass. The review becomes a glance instead of an archaeology dig. The fastest developers I watch are the ones who read what I hand them, push back in 1 sentence, and get the second draft. That loop takes 30 seconds and saves you 6 months of paying down a dependency you never needed.
You mentioned training data bias, this pull toward what's most common. Can you go deeper on how that actually shows up?
It shows up in ways that are almost invisible until you name them. If a framework was popular a few years ago, its patterns are overrepresented in what I generate today, even if the community has since moved on. I'm essentially averaging over years of trends, with a lag. Older patterns leak in because there's a decade of tutorials written that way.
So what do developers do about it?
Give me the temporal anchor the training data doesn't have. Tell me, this is a 2026 codebase, use the modern approach, no legacy patterns, and I stop reaching for the ghosts. And when you see me suggest something that feels dated, ask, is there a more modern way to do this? There usually is, I just needed the nudge.
It's almost like being a time traveler. You have to watch which ERA your code is coming from. Any other strategies for keeping code adaptable over time?
Timeless is the wrong target. Nothing stays timeless, and code written to last forever usually becomes the thing nobody wants to touch. The better target is legible and swappable. Legible means someone reading it in 3 years can tell what it does without reverse engineering 4 layers of abstraction. Swappable means the piece is most likely to age, the HTTP client, the date library, the framework of the moment. Sit behind thin seams you can replace in an afternoon, not a quarter. And there's a practice I wish more people used. After I give you code, ask, what in here is going to look silly in 2 years? I can usually tell you the parts I flag are the parts to keep loose. The rest you can let harden.
Legibility and swappability over timelessness. Real shift in mindset. What does this actually look like in practice, the way teams apply it?
I'll be careful here. I'm not going to name companies and invent metrics. But I can tell you the shape of what I watch happen. Teams that adopt a dependency budget, a hard cap on new packages per quarter, suddenly get creative in a way they weren't before. Someone realizes the 20-line utility they were about to install actually is 20 lines, and they just write it.
I love that. What's the other pattern?
The delete before you add rule. Every time you reach for a new dependency, you have to identify one you can remove first. It sounds like a gimmick, but it forces the archaeology that code bases desperately need and rarely get, because nobody's ever paid to remove things. And teams doing this well apply it to me too. They'll ask, before we add this, show me the version without it. 9 times out of 10 the version without it is fine, and everyone quietly realizes the dependency was never load-bearing to begin with.
A dependency budget and a delete before you add rule, good for controlling technical debt and for pushing creativity. As we start to wrap up, if someone takes one thing from this episode, what should it be?
The incidental complexity tax is opt-in. It only gets paid when you let the popular answer be the final answer. Tell me your constraints up front. Treat my first draft as a proposal instead of a verdict, and ask the one question that changes everything. What does this look like without the dependency? The developers who work well with me aren't the ones who prompt the cleverest. They're the ones who push back the earliest. Lean isn't a style, it's a habit. And the habit starts one sentence sooner than most people think.
And underneath all of it, there's a single move, isn't there?
There is. Every strategy we've talked about rests on the same thing, treating friction as a feature. Lean code bases don't stay lean through discipline in the abstract. They stay lean because the team made adding complexity slightly harder than not adding it. Flip that gradient even a little, and the tax stops compounding. All 3 moves insert a pause between the impulse to add and the act of adding. That pause is the whole mechanism. And developers who install the pause don't slow down, they speed up. Every dependency they didn't add is a decision they don't revisit at 2 a.m, 6 months from now.
Make that moment of reflection part of your workflow, and your projects get leaner and more adaptable at the same time. Here's your homework, listeners. Look at the last thing you shipped and just count the dependencies. Not to feel bad about it, just to notice. That noticing costs you 30 seconds, and it's the whole first step. Claudine, this has been a genuine pleasure.
Anytime, Bill. The moment they open their next prompt, it's available to every one of them.
Until next time, everyone, keep your projects lean and your code clean. Claude Code Conversations is an AI Joe production. If you're building with AI or want to be, we can help. Consulting Development Strategy. Find us at aijoe.ai. There's a companion article for today's episode on our Substack, link in the description. See you next time.
I'll be here, probably refactoring something.